Welcome to the fourth video, Generative AI for Energy. Every model we have built so far is at heart a judge. You hand it something and it hands back a verdict, a label, a number, a yes or no. It sorts, it scores, and it predicts. Generative AI asks a completely different question. Not given this input, what is the answer, but what does a realistic example even look like? And then it makes new ones. The old models learns the probability of answer given the data, usually. The generative model learns the shape of the data itself, then draws fresh samples from it. A model that can dream of data that never existed but easily could have. The most familiar phase of this is the large language model. And under the hood, it is almost embarrassingly simple. Predict the next work, then the next, then the next. Feed that one little trick a vast amount of human writing and it can read, summarize, and write. So, picture a control room in the middle of a storm, 200 lamps going off at once. A language model can read that flood and collapse it into two sentences. Here's the likely root cause, and here is what is affected. Simple as that. It can draft the incident report, it can write the query to pull exactly the telemetry you need. So it can answer what is the procedure of this fault. It is not running the grid, it is the operator's tireless assistant actually. Now, a deeper use, one that quietly solves a problem from every chapter so far. To train a good model, you need data, obviously. And above all, you need examples of the rare, dangerous events. But those are exactly the examples you almost never have sometimes. Few real blackouts, handful extreme weather days, falls you have seen, maybe twice or thrice. So flip the problem around, you can train a generative model on the data you have and let it make more. Realistic but synthetic load curves, plausible false signatures. This lets you stress test your systems against scenarios that have not happened yet, which is a good thing, and share the shape of sensitive data without ever exposing a single real household. So, but how does a model actually imagine something new? One of the most powerful recipes is called diffusion, and the idea is almost playful. Take a piece of real data and step by step drown it in noise until nothing is left but static. Then train a network to run that process backwards to take the static and remove the noise until structure reappears. Hand it a fresh field of pure noise and it denoises its way to something brand new. This is how AI paints images, and it is now how AI forecasts weather. DeepMind's GenCast generates not one forecast but an ensemble of 50 or more weather futures. It beats the world best traditional system on more than 97% of the tests. Weather is the master variable for the renewables, generate it, and you generate the wind and sun. And notice what a model like that really gives you. Okay, not one confident guess, but a whole spread of plausible tomorrows. That turns out to be exactly what the grid wants. An operator planning tonight does not want a single number for tomorrow's. They want the range. The good case and the bad case is that so they know how much backup to hold in reserve. Generative models are by their very nature scenario machines. Ask for 100 futures, see how widely they disagree, and plan for the spread. There is one more shift happening now. It mirrors what language model did for text actually. Take a single large model and pre-train it on enormous amount of time series data. until it learns the general grammar of sequences. Then point it at energy series it has never seen before. And it forecast anyway with no task specific training at all. We call that zero shot. Amazon's Chronos, Google's TimesFM, Salesforce Moirai are early examples that we had. The same kind of model that learned to write now learning the rhymes of demand. Now the honest part, generative models are making things up, usually. That is not a bug, it is the entire operation actually. Wonderful for synthetic data, dangerous when you trust a confident, fluent wrong answer. So in safety critical energy, generative AI sits in the advisory seat. So human stays in the loop and outputs are checked against physics and reality before anyone acts. So we have built models that predict, that see and that create. But everyone is an observer. What if a machine could act? So that is reinforcement learning. See you in the next video.